Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll use implicit differentiation to solve this problem. As per the problem, prove that the curves defined by x squared minus y squared equals k and xy equals p, where k and p are constants, intersect orthogonally for all values of k and p. Orthogonal means perpendicular. So if two curves intersect orthogonally, that means the two curves intersect at right angle or 90-degree angle. This is a very important concept we need to understand and memorize. In this problem, we have to prove that the two given curves intersect orthogonally for all values of k and p. So we have to prove that these two curves intersect at right angle or 90-degree angle for all values of k and p. If two curves intersect at a point at right angle, that means the tangent to those two curves at that point of intersection also intersect at right angle. This is a very important concept we need to understand and memorize. So we should prove that the tangent to these two curves at the point of intersection are perpendicular to each other. For that we have to find dy over dx for these two given equations because dy over dx represents slope of tangent. Let's assume these two curves intersect each other at point A, B. So we have to prove that the slopes of the tangent to these two curves at this point of intersection are negative reciprocal of each other because perpendicular lines have slopes that are negative reciprocal of each other. This is another important concept we need to understand and memorize. Let's start with the first curve, x squared minus y squared equals k. In this equation, k is a constant. We have to find the derivative of this equation with respect to x. Let's start with the first term, x squared. The derivative of x squared with respect to x is 2x as per the power rule. We have to use chain rule to find the derivative of y squared with respect to x. The inner function is y. The outer function is the exponent 2. As per chain rule, we start with the derivative of the outer function. We should use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function y. The derivative of y with respect to x is dy over dx. On the right side, k is a constant. Derivative of a constant is equal to 0. This is the derivative of the first equation. Now we have to isolate dy over dx in this equation. The exponent of y is 1. We can ignore the exponent 1. Next, we can move 2x to the right side of the equation. It will change to negative 2x. We can isolate dy over dx on the left side by dividing both sides by negative 2y. On the right side, we can cancel out the negative 2's. So I get dy over dx equals x over y. We have to find the slope of the tangent to this curve at point A, B. So we can sub in x as A and y as B. This is the slope of the tangent to the first curve at point A, B. Now we can analyze the second given equation. We have to find dy over dx for this curve to find the slope of tangent at the point of intersection A, B. Let's start by finding the derivative of this equation with respect to x. On the left side, x and y are two different functions and they are being multiplied. So we have to use product rule to find the derivative. As per the product rule, we start with the derivative of the first function, which is x. The derivative of x with respect to x is 1 times the second function plus the first function times the derivative of the second function. the derivative of y with respect to x is dy over dx. On the right side, p is a constant, its derivative is equal to 0. This is the derivative of the equation. Now we have to isolate dy over dx in this equation. We can move y to the right side of the equation. It becomes negative y. Next, we can divide both sides by x. I get dy over dx equals negative y over x. This is the slope of the tangent. Now we can sub in the point a comma b in this expression for slope of tangent. I get negative b over a. This is the slope of the tangent to the second curve at point a comma b. Now we can analyze the slope values we got for the two tangents to the two given curves. For the first slope, we got a over b. For the second slope, we got negative b over a. These two values are negative reciprocal of each other. Negative reciprocal of a over b is negative b over a. And these two slope values we got do not have k or p in them. So that proves that the curves defined by x squared minus y squared equals k and xy equal p intersect orthogonally for all values of k and p. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.